As wonderful and flexible as DNS is, there is one small drawback to it in the fact that it is, in fact, easy to fake and for attackers to exploit to send users to locations that they shouldn't be doing, essentially pretending to be a different domain than what they actually are. One of the saving graces for the internet has been the implementation of DNSSEC, or DNS security, that uses public-private key encryption to help secure and sign all of our DNS transfers so that servers can actually trust specific transfers for domain names. Let's check that out. We're going to go ahead and log into, there we are, server DC1. On server DC1, yes, we have AZ800 and MSDCS 800, AZ800.corp. We're going to go ahead and sign the AZ800. We'll see right here under DNSSEC status, it is not signed by default. This is a wonderful process to walk through to get familiar with. I will highlight if you are concerned about DNS security and signing all of your keys, you're definitely going to want to make sure that you have people and time set aside who are capable of handling this in an ongoing process. So let's go ahead and turn on DNSSEC. Just right click, and we want to select DNSSEC and assign the zone. This opens up our wonderful DNS security extensions wizard. Next. Now, what we're going to do is we are going to use the default settings for this zone. However, we want to say that we want to customize it just so we can see some of the options that are available to us. So next, first off, who is the keymaster who is able to sign all the keys for all of the zones in our environment? And we're going to say specifically DC1 is the keymaster. Again, in a large enterprise, you would have a different server as a keymaster. However, in this case, we'll simply go with DC1 to sign its own keys. Next, it begins talking about a key signing key. Remember, this is the keymaster, so we need a key to allow us to create other keys. Next, the key signing key, we want to click Add. Again, we will accept all of the defaults here. We can say generate new keys, what cryptographic processes to use, what key length we might want to use, how to store those keys, what kind of reset signature time spans, as well as rollover frequencies. We'll just say OK, and then next. It then asks for a zone signing key, and for that we'll click next and then add, and pretty much the same thing. Which cryptographic algorithm, how long. You'll notice that this is a 1024-bit, whereas the previous one was 2048. So this is only half as long as the prior one. The signature validity period, DS validity period, and then zone period, as well as the rollover days. Next, choose to use NSEC as opposed to NSEC 3 as opposed to just plain NSEC. Don't need to worry about distribution of trust anchors. We will simply use the automatic update of trust anchors. Signing and polling parameters, yep, again, SHA-1 or 256, as well as some timeout periods. Next, and then next. Finish. At this point, we can now see under DNSSEC status, this shows as signed with DC1 as being the keymaster. If I look into AZ800 and I refresh, we now see that there are several new records in here, including our RR signatures, our DNS keys, our next secure parameters, RR SIGs, NSEC 3s, and so on. This is all of the DNS security that we have added in. to help make sure that nobody else can pretend to be us as we send out updates. Now that we've gone ahead and enabled DNSSEC, well, let's go ahead and disable that. In this case, I'm going to right-click on AZ800, DNSSEC, and unsign the zone. Next, and finish. Much easier to unsign it than it was to sign it. So that's how you both implement DNS security as well as how you turn off DNS security. Those options selected were not necessarily the most ideal options. However, as an example of how to set it up, it was a fairly good sample configuration.